Okay, so this is going to be our second set of notes in Chapter 2. We're going to be looking at what's called a disjunction and a conjunction. So we're going to be looking at solving what's called a compound inequality that's involving conjunctions and disjunctions. Just like the previous lesson, we're going to look at graphing those on a number line. So here's the thing. A disjunction is a specific type of compound statement formed by joining two statements with the word or. So if this is true or that is true, then it's going to make the entire result true. So a disjunction has a correct answer when either statement is true. When you solve a disjunction, you simply solve both equations as you would if they were individual problems. So this is basically a cheap way for me to say, well, on this problem, on example 1, where it says solve the disjunction, we basically have the problem on the left, which would basically be 1a, and the problem on the right, which would basically be 1b, and work both of the equations out to get your answer. So I'm going to start by looking at what I just called 1a. m minus 2 is going to be less than negative 8. So the nice thing about disjunctions and conjunctions is the equations tend to end up being a little bit shorter. So, I mean, we know that the way we get rid of minus 2 is plus 2 on both sides. Negative 2 plus 2 is 0. Got n is less than negative 6. And hey, that one was real easy. Now we go to 1b, where we have m divided by 8 is greater than 1. So just like we learned with inverses, the way we get rid of division is the opposite, which would be multiplication. So 8 divided by 8 will cancel out and be 1 greater than 1 times 8, which is 8. And we're finished with that. Now we'd put those on a number line. So I got to draw my number line this time because I wasn't given one. So I know my first one is at negative 6. I have a less than, so I'm going to put my open circle and my arrow points to the left. Voila, done with that one. Now m is greater than 8. I'm going to put it on the same number line. I know 8 would be to the right of that. And so I've got greater than, that's an open circle, and this time the arrow is pointing to the right. And that's all a disjunction is. Just two small little problems. We're going to graph both of them on the same number line. So example 2, we've got 2x is less than 10, or x divided by 2 is greater than or equal to 3. So basically we got a problem in the first part, which is 2x is less than 10. Now we know to solve that by dividing by 2. On both sides of the equation, we get x is less than 5. Simple. On the second problem, we got x divided by 2 is greater than or equal to 3. So to get rid of divide by 2, we're going to do times 2 on both sides of the inequality. And we have x is greater than or equal to 6. Now on our number line, we graph it the same way we did on the inequality video. So we have 5. So if I've got 3, 4, 5, I'm going to put my open circle, my arrow points to the left, and I've got all the numbers there. Then I've got 6, 7, 8, and at 6, I put my closed circle, and it's going to the right. So this problem is basically saying the solution is any number that's not between 5 and 6. Okay, example 3, we got something a little, it's the same thing. We got first part of the equation, 2n plus 7 is greater than or equal to 27. So we're going to start by solving that. I'm going to minus 7 on each side. We've got 2n is greater than or equal to 20. Okay, so Brooke just walked by, and I'm sorry to Brooke because I said her name wrong. So what we're going to do now is we need to get n by itself. So I'm going to divide by 2 on each side. 2 divided by 2 is going to be 1n greater than or equal to 20 divided by 2, which is 10. We're done with the first half of the equation. The second half, we just have 3n is less than or equal to 30. So I need to isolate my n. I'm going to divide by 3 on each side of the equation. We're left with n is less than or equal to 10. So this is going to be interesting because we got the same number. So I know, well, here's 8. I'm going to say that's 9, that's 10, 11, 12. So at 10, I've got my open circle that's going to the right. And then at 10, I've got another open circle, and this time going to the left. So the whole number line is going to end up being colored in, and that's going to be the solution to the problem. Okay, so this next one, we got a little bit more. I mostly took this one out to get a little bit more help with some of the algebra that we have. So I've got the first equation that I have here before the or. We've got 8r minus 5 is greater than or equal to 6r minus 1. Said on the last video, I like to move the smaller to the other side, so minus 6r. 6r minus 6r is going to be 0, greater than or equal to negative 1. We got negative 5 still. 8 minus 6 would leave us with 2r. Now I need to get r by itself, so I'm going to next add 5 to each side. Negative 5 plus 5 is going to be 0. We're left with 2r greater than or equal to 4. Now I need to divide by 2 on each side of the inequality. We're left with r is greater than or equal to 2. Okay, half done. Now I come to the second equation where we have 4 plus 4r is less than or equal to 3r minus 3. I need to get my r's on the same side, so between 4 and 3, 3 is smaller, so I'm going to take my 3r over here by subtracting 3r's on each side. So that 3r minus 3r is going to leave me no r's on the right with a negative 3. On the left, we have 4r minus 3r would be 1r. We still have that plus 4. Next thing we need to do is get rid of this plus 4. So I know to get rid of plus 4 with a minus 4. 4 minus 4 will leave us with 0. And then 1r is less than or equal to negative 7. We've got our two solutions. Only thing we have left to do is put it on a number line and call it good. So we have r is greater than or equal to 2. So I've got my 0, 1, 2. Since it's greater than or equal to, I'm going to put my closed circle and the arrow going to the right. The second one, I've got negative 7. So I'm going to kind of skip from negative 1 over closer to negative 7, negative 6, negative 7. And at negative 7, I know it is a filled-in circle because it's or equal to. Arrows pointing to the left, and that's how we do a disjunction. The next thing that we have is a conjunction. Okay, conjunction is going to be a compound statement formed by joining two statements with the word and. A conjunction is only true when both statements are true. So here's a huge tip. Solve each problem just as you would doing a disjunction, but when you go to graph it in different colors. So like a pencil and pen, two different colored pens, maybe a highlighter, or different colored highlighters. And what that will let us do is a little bit of something. We have to do one final step when we have a conjunction. The answer to a conjunction is where the colors on the graph will overlap. And so we have to write it as an interval, just like we were doing on the last assignment. So we've got our first example of a conjunction. We have x plus 8 is greater than or equal to 9, and x divided by 7 is less than or equal to 1. So just like a conjunction, I'm going to take my first equation here. This x plus 8 is greater than or equal to 9. I'm going to work this one out, so I know to get rid of plus 8 with a minus 8 on each side of the equal sign. Which leaves us with x greater than or equal to 9 minus 8, which is 1. Okay, now we go to the second problem. X divided by 7 less than or equal to 1. So just like the last problem, for the last set of problems, we know to get rid of division with multiplication. So I'm going to do times 7 here. So times 7 divided by 7 will cancel out. We got x less than or equal to 1 times 7, which is 7. Now when I go to my number line, I'm going to graph the left equation in blue, and I'm going to graph the right equation in red. So I've got 0, 1, 2, 3, 4, 5, 6, 7. So my left equation, I know it's 1. We've got the filled in circle, and the arrow is pointing to the right. Now on my second equation, we have 7. So I've got my filled in circle here, and it's going to the left. So the way I'm going to write my answer is the part that's overlapping. I can see I've got red and blue from 1 to 7. So my answer is going to be the interval of 1 to 7. So it does involve that last little step where you have to interpret your graph. Okay, next problem. Now this one's phrased a little bit differently. Okay, so we're going to take the equation and we're just going to split it in half. So what we do is our first problem, we have negative 36 is less than 3p minus 6. So we're going to take that equation and we're going to solve that. So I know I need to do plus 6 plus 6. Negative 30 plus 6 would leave us, negative 36 plus 6 would leave us negative 30 is less than 3 times p. To get rid of times 3, we divide by 3, which leaves us with 1p is greater than negative 10. Now I know in a case like this, I've got my variable on the right side, my number on the left. I'll just want to flip-flop the order and say it's p is greater than negative 10. Now the second problem on this is kind of hiding. We're going to do the second half. So we're going to take 3p minus 6 is less than negative 15. We work this out the same way we did the last one, so we're going to do plus 6 plus 6. We've got 3p is less than negative 9. Next thing we need to do is divide by 3. And we've got p is less than negative 3. So the variable's on the left side, so that's okay. Now we're going to come to our number line, and we're going to just kind of, well, I've got zero, I'm going to say zeros here. That means that's negative 1. I'm only putting my negatives here because that's all I'm dealing with. I'm going to skip a few spaces. I got negative 9, negative 10, negative 11, so on. So I know negative, the one on, I'm going to change my mind. I'm going to go with the one on the left in blue. So p is greater than negative 10, so I'm going to put my open circle at negative 10. It's going to the right. My second equation, I've got my answers. P is less than negative 3. So I've got my open circle at negative 3 and my arrow going this way. So I can see the two parts that are overlapping is negative 10 to negative 3. Now the open circles. Open circles are different. On open circles, we should use parentheses. So this is going to be the interval of negative 10 to negative 3. So this is saying all the numbers in between negative 10 and negative 3 would be the solution. Make sure you analyze the graph to get your final answer. Got one more problem I want to do. Okay, so example 7, we got 5x minus 5 is less than negative 7x minus 5, and 3x plus 5 is greater than or equal to x minus 1. Okay, so what we're going to do is we're just going to take this, we're going to work out this first problem, 5x minus 5 is less than negative 7x minus 5. And I need to get my variables on the same side, so I've got my 5x, I've got my negative 7x. Negative 7x is smaller, so I'm going to start by adding 7x to both sides. So 5 plus 7 will give us 12x minus 5 is less than or equal to, or less than negative 5. So I add 5 to both sides to start isolating that variable. I'm left with 12 times x is less than 0. I divide by 12 now. 0 divided by 12 would be 0. So that's going to be my blue line. And now we're going to do the other one, which is going to be in red when we graph it. So we got 3x plus 5 is greater than or equal to x minus 1. I'm going to group my variables. I've got 3x and x. So to move the x across the inequality, I'm going to minus x on both sides. 3x minus x would leave us with 2x plus 5 is greater than or equal to negative 1. I'm going to subtract 5 on each side to get rid of the plus 5. 5 minus 5 would be 0. We've got 2x greater than or equal to negative 6. And finish by division by 2 to undo times 2. We're left with x is greater than or equal to negative 3. So that's going to be my red equation. Now I'm going to come to my graph. So I've only got, the numbers are fairly close together. I've got 0, 1, 2. I don't really need the positive number, so I need the negatives. -1, -2, -3. And I can see, well, at 0, I have an open circle because it's less than, and the arrow is pointing to the left. On the right side, on the red equation, I have -3 with a closed-in circle, and this time it's going to the right. So when I write my interval, I've got -3, and since it has a filled-in circle, that corresponds with a bracket. Ends at 0 where they overlap, and at 0 we're going to put a parentheses because an open circle corresponds with a parentheses. So just like the last video, I want you to write down any questions that you may have at this point in the margin on the left and be prepared to discuss in class. Thank you.